How's it going, everybody? Thanks for coming to see me. I think the abstract for this talk was something to the effect of like, it'll be Josh Wills talking about stuff with no additional substance or whatever. So I guess thank you all for coming, I suppose, for that. Or for those of you who just basically were sitting in the room and forgot to leave for a more interesting talk, I'm sorry, I apologize. A little bit about me. I am currently Slack's head of data engineering. I've been in Slack for about 6 or 7 months now, which I think makes me like an old timer in sort of Slack years, since the whole company is like 2 years old. I worked at Cloudera for 4 years before that. I was director of data science there. I used to work at Google for a while, and I ran data science teams and data engineering teams and all that kind of good stuff. I wrote a tweet once about data scientists that you've almost certainly seen and that I never want to talk about ever again. And my first job at Google was advertising. So like when you ever did a search on Google, like 2007, 2008 sort of time frame, and ads showed up, that was me. Working on the ad system, working on the auction, figuring out where ads should go, how much people should pay, all that kind of good stuff. You're welcome. Nobody ever thanks me for that. Ever since then, I've been trying to do work in order to make up for my couple of years spent as an advertiser, sort of like a penance or a karma or something like that, with varying degrees of success. So, I worked at Cloudera for a guy named Jeff Hammerbacher, who has this famous quote, the best minds of my generation are thinking about how to make people click on ads. That sucks. And it's probably another quote that you've seen if you've done any stuff in data for any period amount of time. Jeff went on the Charlie Rose show once and said that that quote will be on his tombstone. And he's probably right. That's probably going to be like his most lasting contribution to Western civilization, right, is roughly that quote. And I have like some sort of personal experience with the quote because I don't know. So it's not really a humble way. There's no Hallmark card for saying I am one of the best minds of my generation. I'm not one of the best minds of my generation. I'm like the guy who hangs out in the room with the best minds of our generation and like brings them coffee and sandwiches and stuff like that. So I'm not in the club, but I'm like sort of next to it. And I was working at Google for a long time, and Jeff was trying to recruit me to Cloudera. And you know, basically, his ultimate technique was to get me to realize that at the end of the day, anything you're doing at Google or Facebook is fundamentally devoted to advertising. Like that's sort of the point of it, right? No matter what you're doing. There was actually a great quote I just saw on Twitter, like literally 5 seconds ago, and I'm going to read it because it was really funny. Google's doing I/O right now, right? And this guy tweeted, "Google products are like the massages given to Kobe beef. They're not for the benefit of the cow. They're to make the cow a better product." Yeah, think about that one for a second, right? But that's actually like pretty goddamn good, right? I'm going to go ahead and retweet that right now. Yeah, there's some truth to that, y'all. Like, not for nothing. There's some truth to that. So anyway, the way Jeff got me to go work at Cloudera was to get me to realize that at the end of the day, I really personally don't care whether Google or Facebook is the dominant advertising force in the world. Like, I really don't. Like, I mean, honestly, who cares, right? I guess, like, maybe, you know, Larry and Sergey and Mark, maybe those guys care because it's like $1 billion here and $1 billion there or whatever. But, like, I personally, I don't really care. I wanted to go work at Cloudera because I wanted to go work on other stuff. I wanted to go work on healthcare stuff and oil and gas stuff and climate change stuff. And there's like lots and lots and lots of other stuff that we can do with all of this great, great data technology that's been invented over the past decade or so. But as I've spent like the last, I guess, 6 years now, like sort of removed from ad tech and not doing ad tech anymore, I would be lying if I said I didn't miss it a little bit. And I want to kind of talk about why for a bit, because I've been thinking about this lately, like working at Slack. Why did I get into advertising in the first place? Well, it's because there's honestly a lot of money in advertising. It's like, why do people do, you know, like subprime mortgages and stuff like that and work at hedge funds? It's because there's like a lot of money there. And there was a lot of other sort of great stuff that came along with that money. And then one of the things was just like really, really, really smart people working on really, really interesting, hard problems. And sort of putting their solutions out there and like releasing them as open source software that anyone who was basically as smart as they were and capable of running the stuff could use to work on any problem that they were interested in, right? So all of the stuff around Hadoop, all of the stuff around Kafka, really all of like basically all of the nice stuff we have is through the largesse of these very, very profitable advertising companies that just gave all this stuff away largely as a technique to recruit other software engineers, more or less, to come work on their awesome stuff. So I don't want to say that like advertising is purely a bad thing. It's not. It's created a lot of very, very cool stuff and solved a lot of really interesting computer science problems over the last 10 years in a way that is sort of open and available to everyone, and that's a very worthy thing. And sort of the other thing that I loved and is maybe like talked about a little bit less, I loved the culture of working on really, really large-scale machine learning problems. I loved working at a place where like the stuff that I did was really the center of the universe. It was like the center of what the company did in some sense. And everyone was really aligned around data, infrastructure, like really, being sort of true to ourselves and being like more so than anywhere else I've ever seen, actually like following the scientific method, right? And really, really running experiments and not relying on the sort of the highest paid person in the room. Realizing that everybody was in this together, having like world-renowned machine learning researchers carrying pagers because they were on call for ops duty support. Just the culture of working in advertising, doing like large-scale ad tech, like just basically big-ass logistic regression models, is actually really, really great. I am still like really good friends with most of my peers from my Google days, just because that experience of working together on something like that was super fun. And just in many ways, probably like the best working experience of my life, including all the stuff I've done at Cloudera, and honestly, including all the stuff I've done at Slack. I've never had that sort of, I have a friend who's a Michelin star chef, and she says that like working in a really great kitchen is like that. It's hard, it's high pressure, but everyone is working towards the same thing, and everyone is really, really good at what they do. And it is a phenomenal working experience. If you ever have the chance to do it, I highly recommend it. But at the same time, I guess I'm a little worried about, I don't know how to quite say this. We've gotten really, really, really good at building machine learning models for ad tech stuff. Really, really good at it. And in fact, we've gotten so good at it that there aren't really any people involved in advertising anymore. At least to the extent to which people are involved in sort of at best a tangential sense. And what I mean by that is there are algorithms that are so complicated that no one can understand them, deciding what ads to show. There are algorithms on the other side, like in botnets and stuff like that, that are clicking on the ads that are so complicated that no one can understand. There are other machine learning algorithms on the other side that are trying to defeat the bots, and it's just basically like, it's just essentially, it's an army of machines battling out over this world that like a human occasionally like stumbles into the killing field sometimes and like clicks on an ad. But there's no people there. It's just all machines, it's all computers. Yeah, and I don't know about y'all. I mean, I'm pretty introverted despite what I'm doing right now. But I basically like people. I don't know, it's like one of those things. Like one of the things I like about Slack is there are people there, right? There are people and there are bots, but there are definitely people. I'm reasonably sure, yeah. So yeah, I guess it kind of feels to me in the same way that I think maybe people who've been doing hedge fund stuff for a long time, it can feel just sort of empty and draining and just abstracted away from anything that matters at like a human scale. In a way that is just ultimately like not nourishing. It's just like eating a bunch of candy or junk food or something like that. It feels very rewarding at the time. See the thing about the picture of me at my house swimming around in my big giant, whatever, warehouse full of money. But it's ultimately not like good for you as like a person, basically. Yeah, I wish I made that a little bit crisper, I'm not gonna lie, but let's move on. So I've left advertising now, and I've left it for quite some time, and I'm sort of out, on my own in the sort of Les Miserables sense of the term. And I sort of like miss advertising, and I miss parts of the camaraderie, I miss the sort of the sheer awesomeness of my colleagues and stuff like that. But I do generally feel better about the work I do every single day. It is like more rewarding and more meaningful to me. And I think the thing that I really miss the most, the thing I miss the most is the camaraderie. The thing I miss the most is the relationships. It is the sense of everyone being in this together. And it's the thing that I feel like it doesn't exist in sort of the the non-data world. Like, it doesn't really exist yet at Slack. I don't think it exists at most of the companies in the world that are doing sort of non-ad tech stuff. And I want to talk about that a little bit, because in order for data to really, really, truly take over, then we need the best people in the world to not be thinking about clicking on ads. We need them to be thinking about these problems. And the way to get them to think about these problems is not just about technology, and it's not just about money. It's about the culture, and it's about the experience of working at these places that we need to talk about and we need to solve. And so I'm not going to solve the problem today. Obviously, this is just a talk. But I do want to talk about my experiences and roughly like how I think about these things. I thought the slide would advance. There it goes. So let's talk about analytics and engineering. That's kind of where things start here. I kind of feel like, in a lot of ways, I think like for my next career after I leave Slack, I'd like to become a therapist for data people, roughly speaking. That's actually what I would like. Oh, thank you. Okay, that's a few. I don't know. I kind of feel like I played this role in a sort of ad hoc sense now. I have basically friends who are the first data analyst or the first data engineer working in a company, and they reach out to me because they're basically having a horrible time and they're very unhappy and they think there's something wrong with them. They think that they are stupid, or that they should be way better at this stuff, or other companies are more data driven than they are, or something like that. And it's really not true. It's horrible for everyone. You're not alone here. And I feel like a lot of my sort of, the value I provide is just telling people that, right? And I feel like in some ways though, even at Slack, where we have a devoted analytics team and a devoted data engineering team, in some ways we're not alone anymore. There's not just one person, there's a team there. But we still have a bunch of problems. We still have a bunch of sort of cultural sort of rifts that we have not solved yet, and that we need to talk about and need to figure out how to solve. And again, we're a little bit bigger and a little bit more successful, but we haven't solved these problems yet. So even the sort of larger teams need some kind of group therapy or couples counseling or something like that in order to be able to work together better. And I think where it starts is trying to figure out what exactly is it we both want out of our relationship. What do the analysts want? What do the engineers want? What do the data scientists want? What do the data engineers want? Insofar as I can tell, data scientists want to build really, really cool models and really, really cool metrics and dashboards that fundamentally change the way people think about a problem, or either the executive level or whatever, and then go talk about them at conferences so they seem really, really cool to all the other data analysts and data scientists and stuff like that. Data engineers, on the other hand, want to build truly awesomely scalable, very, very reliable systems that handle all failures perfectly and that deliver data exactly on time and are super awesome and fantastically amazing. And then they can go at conferences and talk about how awesome they are at scaling and reliability and all that kind of good stuff. So fundamentally, we both want to go to sort of our separate conferences and talk about how awesome we are at our separate things. But the reality is these two goals are almost always in conflict with each other. Building things that are reliable and scalable means that they're probably going to be fairly simple and not necessarily that interesting, at least from a data scientist perspective. And doing all of these sort of crazy shit that a data scientist wants to do in R or Python is not going to satisfy the reliability or scalability needs of a data engineer. So when we're not all working towards the same sort of productionized machine learning kind of problems, we end up wanting different things. And that is sort of the core of our relationship problem. We want different things out of our relationship. And really the problem is not just data engineering and data science. This is maybe hopefully my other major contribution to Western civilization will be talking about the infinite loop of sadness. And it's all about the relationship between ops, data engineering, data science, and the business. And essentially, unreasonable requests flow around the loop, the infinite loop of sadness. So the business has no understanding whatsoever of what is and what is not possible with data, so they make ridiculous requests of the data science team. The data science team wants to run basically terribly unscalable algorithms on brand new hardware, on untested versions of Hive and Presto, and they basically force the data engineering team to deploy this garbage into their clusters so that they can use whatever shiny new feature that they are super excited about. The data engineering team is making insane requests of ops in order to build their super ridiculously scalable storm pipelines that could have been easily solved by a Kafka consumer that was a bash script. And the ops team goes around to the business and asks them for a ton of money because they need it to support all of this crazy stuff that everyone else is trying to do. And the cycle basically spins out of control. It just kind of keeps going like that. Because then the business is like, well, we're spending all this money. We ought to be getting all this ridiculously cool analytics that we want, blah, 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 blah. And you can kind of see how this sort of goes out of control. I don't really know how to solve this problem. But again, let's just start by talking about it, right? This is the nature of the relationship between all these different parts of the organization. And as a result of this, I think we end up being like alone together. Like we're sort of next to each other, we're living our lives, but we're essentially, everyone in this, like basically everyone in this loop is constantly trying to outsource the adjacent people in the loop, like more or less, as far as I can tell. The data engineers want to automatically pump data into a system that automates what the analysts do. The analysts want to, so on and so forth. Okay, good deal. So what do we do about this? What do we do about this? Like, what is the solution to this problem? Again, I don't know. I'm probably going to keep saying I don't know as like a general theme of this talk. But let's start with first principles, all right? And the first principles are, at least for me, at least recently working at Slack, in order to build data infrastructure, you only need to understand and appreciate two things: Apache Kafka and Franz Kafka. And Apache Kafka is obviously important. It's like oxygen for data people. But nonetheless, the Franz Kafka part is even more important. I'm going to quote sort of a little bit of David Foster Wallace here. He wrote this great essay about Kafka's sense of humor. It's in a book called Consider the Lobster if you want to read it. And basically he's saying like students can't understand Kafka's sense of humor. They can't appreciate the really central Kafka joke, which is that the horrible struggle to establish a human self results in a self whose humanity is inseparable from that horrific struggle. And the same is basically true of data infrastructure. The horrific struggle to establish data infrastructure results in a data infrastructure that is inseparable from that horrific struggle. It's horrific for everyone. It's absolutely terrible, sort of like bubblegum and toothpick sort of like jammed together disaster for absolutely everyone. You're not alone here. And that disaster is our home. Like that is where we belong. It's not something we can ever really escape. It's what we're here to do, more or less. So instead of having an infinite loop of sadness, we really need to have an infinite loop of empathy. And in particular, it needs to be an infinite loop of empathy between data engineering and data science because we have similar relationships. Like the data engineers should understand that from the analyst perspective, they are like the ops team. And the data scientists should know that like from the data engineer's perspective, they look like the business team because they effectively are, right? And if you bring that kind of empathy to sort of think through what is this like for the other person based on your own experiences, I think it becomes easier for us to work together. Now, like I said, machine learning, if you can do sort of production scale, serious, large scale machine learning, it's relatively easy to get everyone on the same page. But a lot of companies don't really need to be doing large scale production machine learning. Like it's not really necessary. But everybody needs to do ETL. Everyone needs to extract data from somewhere, perform some transformations on it, and load it somewhere else. This is an absolutely brilliant comic, by the way, and the fact that more of you aren't laughing is like making me judge everyone in the audience right now. But like go back and watch this later. Everyone does ETL, and the way that you do ETL to me says a lot about the data culture inside of your organization. So the first option I've seen, this is sort of like Facebook SQL-centric ETL. At Facebook, every ETL pipeline is basically a Hive job, Hive or Presto for absolutely everything. It is a very SQL-centric kind of ETL that any analyst or data scientist can do. And data engineers at Facebook are assigned in kind of a relation. There's roughly one data engineer for every 2 data analysts, roughly speaking. And the data engineer is essentially the data analyst slave. They write UDFs, they optimize pipelines. They're basically like the servant of whatever crazy goddamn thing the data analyst wants to do. And this is like, as a sort of data engineering person, like not a healthy or good relationship. I don't like advocate this relationship, but this is fundamentally what happens when data analysts are kind of fundamentally running the show when it comes to doing data at your company. Option 2, I'm going to call out Twitter for this one. Twitter is the land of the JVM-centric ETL, where in order to write an ETL pipeline at Twitter, you'd better have a sort of advanced degree in abstract algebra and know your sort of monoids and rings and principal ideal domains really, really well. Essentially, like at Twitter, the core ETL pipelines are completely automated, completely written in Scala, and basically maintained by a high priesthood of engineers who occasionally deign to let the data analysts like look at some slice of the data if they feel like it. Now again, this is actually much more appealing to me as a data engineer, but I don't necessarily think of this as like the optimal state of affairs either, okay? So what I want to come up with at Slack is a third way. A third way that makes this really, not the ETL thing, nothing but this. Okay, fine. A third way that basically makes everybody equally unhappy. That's what a third way means. A line break after every sentence. I mean, that's just the worst. Anyway, what does the third way look like? There's a bunch of different sort of attributes of like data stuff now that are sort of informing the way that I want to think about this third way. The first and foremost is the rise of Spark. Spark is, if data is the new oil, Spark is the new standard oil. Spark has its tentacles into absolutely everything. Spark is completely unavoidable if you're doing any kind of data stuff, at least in San Francisco these days. All right. Thing two, there are way too many goddamn streaming engines right now. At Google, we had this great joke. There were two ways to do anything, the way that was deprecated and the way that didn't work yet. Batch processing is deprecated and stream processing doesn't work yet. That's the problem we have. None of these things actually work aside from Kafka. Like Kafka is the only thing that works. Spark streaming, oh my God. Like what a dumpster fire, all right? It's just the absolute worst, okay? Like, it's like, I want to slap them. Like, who taught you to manage memory, for the love of God? Okay, anyway, leaving that aside. There are too many streaming engines right now. I have to pick one. I need to deploy a streaming engine to serve some analytics to Spark platform developers, or sorry, to Slack platform developers. That's Spark's, again, the tentacles are everywhere. Slack platform developers. I don't know which one to choose. Whichever one I choose will be wrong. That's all I know, okay? There's too many of these things. That said, the nice folks at Google, like the Cloud Dataflow team and the Apache Beam community, have put out some really, really, really nice design patterns and some really very cool new ideas for thinking about how to handle like late arriving data and like real world data pipelines that resonate with a lot of my friends who are like thinking about these problems and have been experiencing them lately. Like making windows and time a first class primitive in your data pipeline abstractions is basically a really goddamn good idea and something we should have thought of a long time ago. So even though all of these engines are terrible, we roughly know sort of in a broad sense what patterns are right for solving this problem, all right? And last thing, the real problem of data engineering, of data science, is change. That is the real problem. It's not scale. Scale is not a real problem anymore. It's not a real problem at Slack. It's honestly not a real problem at anywhere besides like Google and Facebook. If you are not Google or Facebook, use the thing that Google and Facebook open sourced. It will solve your scale problem, okay? The real problem is change. How do we handle evolution? How do we handle backfills? How do we handle recovery? That's the real problem of data engineering that is not super sexy to talk about at conferences, but is actually the thing we need to solve. And so with that, I think I have like 30 seconds left, but that's fine. I'm taking some inspiration from deep learning. I can just go? Okay, cool. All right, I have some inspiration. Yeah.
The talk that starts at 2:30, it's in the female room, but I'm going to break the rules and let him talk if you don't mind.
All right. Thanks. Sorry, I won't hurt my feelings if anyone has to leave. It's okay. As I think about solving these problems, building data infrastructure at Slack, I take some inspiration from deep learning. Between like Torch and Theano and TensorFlow, we have this pattern of a high-level scripting language, like be it in Python or Lua or whatever, that supports and integrated with a very low-level, high-performance engine in C++, using GPUs and all kinds of crazy stuff in order to do the really, really hardcore processing at the core of these deep learning models. And that's the kind of pattern I'm into for data engineering as well. I think we need a high-level, very, very flexible scripting language for doing just the absolute brain-dead stuff we have to do all the time, and a low-level engine for doing the high-performance aggregation stuff that we do all the time, that we know how to optimize, and that we know we need to run really, really efficiently. The other thing that's interesting to me, like these days in sort of programming, is this evolution of like not quite static typing. And this is like the flow language on top of JavaScript or Hack that Facebook released. This idea of like evolvable sort of typing where you can kind of go from like a completely dynamically typed environment to a completely statically typed environment on your own pace, whenever you feel like. And while for a long time I've been a major advocate of true static typing for data pipelines, I feel that now with Spark, with being able to load data sets in memory and cache them and work with them interactively, I've become much less obsessed about static typing. It's just the cost of like a type error has gone down to the point where like I appreciate the flexibility and the speed of a sort of dynamically typed language when I'm doing interactive analysis. And then even better, when I want to productionize that and turn that into ETL, the ability to like add types to it seems like a really, really good solution to me and seems like a great way of approaching the problem. The other thing is that, you know, I work at Slack, and once upon a time, Slack was this really cool game called Glitch. And Glitch was a game engine, and the game engine was written in Java, and the game engine had a level designer that was written in JavaScript. So as it happens, at Slack, I had a really, really good Java engine that could support scripting from JavaScript already available to me. And the result of this is something that you're probably going to be horrified by, but that's okay. I am basically writing a sort of ETL description language entirely in JavaScript running on top of a Scala runtime engine. No one's thrown anything at me. That's awesome. Okay, that's great. The way this works, yeah, exactly, right? Everyone's too stunned and horrified to say anything. The way this works is you declare tables and you declare schemas for those tables that have column names and types and aggregations and all that kind of good stuff. And that's executed in Scala. Scala parses the JavaScript via the Nashorn engine, turns it into some objects and does the actual execution. But then kind of like your flat map function can be done written entirely in JavaScript. It can be tested locally, it can be tested in a browser, whatever you want, and then deployed out onto the cluster as part of like an overall sort of large scale pipeline. The Scala engine takes care of the orchestration, wiring everything together, and making sure that everything runs in the correct order. The cool thing about this for my analysts is they don't really have to write UDFs anymore. They don't have to delve down to the internals of Hive and Presto. They can just like write their scripting functions directly, like things they would do as UDFs, can be done much cleaner and in a much more testable way immediately in JavaScript. Everyone hates JavaScript, and that's great because it's like if you can't program JavaScript, you basically can't program. Does that make sense? Like every programmer hates JavaScript, but because they hate it, they have to know how to do it. Because otherwise, okay, never mind. That's fine. Take my word for it. It's pretty cool. All right. C Kafka, exactly. Additionally, though, because of the magic of Spark SQL, we can still incorporate SQL into this sort of flow whenever we need to. So if I need a lookup table or if I need to do a join as part of the output to a pipeline, I can always fall back to SQL and have Spark SQL do all of the heavy lifting for me, which is fantastic. And so, yeah, this is roughly speaking the brave new world I'm trying to create. I want to create a meaningful collaboration between data analysts and data scientists on something fun that satisfies both of our needs. It satisfies our need for real-time, large-scale streaming pipelines. That satisfies their need for flexibility, for exploration, for all the kind of good, cool stuff they get from data science. And then we can all sort of live together in a harmonious, you know, like magical tower, whatever this thing is. Like that's where we're going to live together. It's like a biome or something, whatever. And yeah, with that, we're hiring. And if you'd like to help me hack on this stuff, we'd love to have you at Slack. Thanks very much.
Thank you very much, Josh.
2 minutes to spare. Tons of time. Yeah.
Tons of time.
Tons of time.
I'm hoping there are lots of questions. Please, please.
Oh, okay. Are there questions?
Are there
If there are
questions?
questions over there, I'm not going to be able to see you, so just as an FYI.
Oh, I'm handing it, sorry.
Oh, okay, cool. All right, you can see, though, because
Yes.
you're down there.
Yes.
That's okay. How's it going?
Great, Josh. Any tips on how to do the metadata management? I noticed you're sort of hard coding some table definitions in there.
In that kind of stuff?
How do you manage the simple task of the sharing of that information?
Oh, so I think for us, at least at Slack, like a lot of other sort of cloud-native companies, we have a centralized Hive metastore that is our like single source of truth for everything. The definitions in like external thrift files or in like these JavaScript files basically automatically propagate. Whenever we're kicking off a job, we compare the output table definition from the JavaScript to the existing table definition in Hive. And if there's going to be new columns, we just automatically add the new columns. And if you add columns in a way that is incompatible with the existing schema, we fail the job and we don't let you run any further. But I think for a lot of us, you know, it's not perfect, but I think the Hive metastore has become the closest thing to a centralized metadata manager that is practical and fairly useful and all that kind of good stuff. So. Yeah.
Anyway, good talk. Lots of things to go with, but how about this one? You seem pretty calm and attached with the Apache collection of tools, and that's not the only game in town.
No.
But it's and also a sub question of that is that Spark SQL is pretty relatively new.
Yeah.
Relatively new, and it's very central and unquestioned in your talk there.
Yeah, it's actually like not that terrible, I guess. It's sort of like the thing. Spark SQL's been around for a couple of years now, and it sort of, yeah, no, it has. So I'm sorry, Shark has been around for a couple of years now, right? The thing that runs like Hive on top of Spark, and that's basically the way we use it. Like that's sort of, it's if you want to run an inline Hive query. I mean, yeah, like the Catalyst optimizer gets things wrong sometimes, and Tungsten's kind of a pain. You need to turn it off, but like it basically works. And you know, the sort of interaction, like really the nice thing is having the clean interaction between, like you know, I fault Spark for lots of things. I will never run Spark streaming like over my dead body. But for batch processing and for doing kind of the clean integration of SQL and sort of arbitrary Scala or arbitrary whatever, it's actually pretty good at what it does. There's a lot of stuff that's like just a little off. You have to hack around, and that's annoying, but like it's basically pretty good at what it does. So that's me being nice to the Spark developers. That's what passes for me being nice. Anyway. Yes.
You mentioned that technology is either deprecated or not working at all. Where does Slack kind of fit in that continuum?
Oh, that's a great question. Email is deprecated. Slack doesn't work yet. Yeah. No. I can almost like a lot of times I feel like you know you go around San Francisco, people tell you how much they love Slack, and I'm like, really? Why? Like you live on this side of the fence. It's like, God, this product is terrible. Like, oh my God, I can't believe we charge people money for this. This is horrible. We need like a ton of work to do to make Slack not terrible. All right, cool. Ripping on my own product.
Thank you
Awesome.
very much, Josh. Yeah.
Thanks everybody.